Hello. I'm sorry, that was weird. It's been a while. Hello, everyone. We are joined here today by Ben Zhao, a brilliant professor who will, in a second, share about his current work and brilliant papers that we all enjoy reading and his post on LinkedIn. We will talk about model provenance, watermarking, distillation, all the good stuff that everybody's been talking about, or maybe not. And yeah, without further ado, Ben, please introduce yourself and please tell us, why are you here today talking about model distillation and AI slop?
Okay, thank you, Elena. So my name is Ben Zhao. I'm a professor of computer science at University of Chicago. I've been a professor for a long time. It's starting my 23rd year, I think. I mostly work on security, but really in the last decade or more, I've been more focused on AI security. And the last few years with generative AI, I've been focused a lot on obviously security and trustworthy and privacy issues with the new generation of AI models. When they're misused, their harms on sort of people who choose to use or not use them, and society in general. So there's a lot of different topics that I cover, everything from um, how to sort of disrupt or break models that perform non-consensual training on data that don't belong to them, to things like understanding the arrival and the growth of AI slop in all sorts of different creative contexts, writing, music, websites, even research articles in the research community, and how that's affecting many of us in different communities, but also other things like, just technical questions, fun things like model distillation and why that is or is not a practical thing to be debating. But yeah, lots of fun things that are relevant to everything crazy about AI today.
How crazy. We will dive deeper in this episode, I'm pretty sure. So,
Oh no.
oh, yeah, let's start with a slop, music in particular. And obviously, it's been everywhere, and I'm not even talking about music, but yeah, slop in general. But for the purposes of this discussion, Ben, I want you to give us a short definition. Not that we don't know, but pretty much for everyone otherwise not involved. Uh,
Sure.
what would be AI music slop?
Yeah, I mean, I guess slop is in general more of a newly coined term for, effectively speaking, AI spam, right? So content that's generated by AI with minimal effort in very large quantities. And in the context of either art, images, or writing, or web pages, or more increasingly music, there's a large amount of AI content that is now easily creatable with prompts. Takes you 20, 30 seconds, perhaps sometimes even less, to effectively create content that looks like it came from a human being, um, but really has minimal intent and is really automated just to increase volume, right? So um, I'm sure it's not news to people that if you are on Spotify or Apple Music or any of these streaming platforms, you're increasingly exposed to AI generated music that effectively can be created using, 20 word prompts or even less. And moderators, sorry, and generators like Suno and others will generate full, end to end songs that sound really legitimate, with lyrics, with, a particular consistent voice for the entirety of the song, with lyrics that sound like they're written by humans, background vocals, instrumentals, everything. And if you're on Spotify, if you're on Apple Music, it is increasingly difficult to detect when you're listening to one of these songs. And so we conducted a study that really spanned sort of winter, late fall of 2025 and early spring of 2026, just showing how much of this there is and where it's coming from. And the short version, is really that even as of, I think, before Thanksgiving 2025, uh, from a daily or weekly basis, AI music was already, there was already more new AI music that was arriving than new human music, right? So increasingly, the library that we're exposed to or have to choose from or can choose from on these platforms are AI generated. And if you look closer, many of these tracks, or I should say, most of these tracks, are actually produced by a very, very, very small percentage of AI users. You can, we can quibble about sort of the quality of AI musicians and whatnot, but there are people who are using AI tools to legitimately try to create real music with intention, with design, with thought processes. But there's a very small portion of AI users who are generating more AI tracks than anybody else. Something like 3% of the AI musicians are putting out more AI tracks than all other AI users combined. Some of the more egregious groups are producing roughly, I think one of the numbers is, one group is producing about 64,000 tracks per month. So if you do the math, it's basically, one track per minute, 24/7, nonstop. So
In the
yeah,
paper, in your paper, I love the use of the phrase "spray and pray." Is that what you're referring to? Can you
yeah, yeah,
talk a little about that? So the way you
sure.
describe it in the paper, the AI musicians who are releasing all
I'll
this stuff, they're just releasing a ton
I'll
of songs and praying that one of those songs will hit jackpot, etc.,
hmm.
etc. I just really like
Are
the
we
phrasing
sure?
of this.
Are we sure these quote unquote AI musicians are actually humans, man?
Well, I mean,
Could it be
there
just,
are some
somebody
people
built,
behind it.
I mean, somebody built an agent or, yeah, bot who will just running around and just flooding the internet with this content. Um, yeah, that's my first, I guess, kind of observation, or maybe, I mean, not even a question, but just kind of a thought that I had. And also the
Yeah,
second is that since you were talking about Suno, I would have to bring up the recent news from Germany and also the BMG licensing deal, right? So I know you have been following all the lawsuits very closely, and even, you know, and also, testifying California legislature about those things. But this is something very interesting from the world of AI music, is that, German courts is just notorious being very like pro plaintiff, I think, in general, kind of a very strict jurisdiction. And here they ruled against Suno, right? The plaintiffs were, I think, the authors, not the guild, but just kind of an organization representing collectively the authors, and the German court ruled in their favor that Suno's, training did train their models on unauthorized content, and like 10 weeks after Suno signs a BMG licensing deal, too,
yeah.
right? So, did you have any part of that in that?
No,
Like,
I was not part of that trial, but that was a very interesting
okay.
outcome.
Mhm.
Obviously, I think in general, the European courts and legislatures, for that matter, have a much more practical and sort of pragmatic view towards many of these legal issues than the US. So that was really nice to see. I think there are also some interesting tidbits that fell out of that trial in the process, including disclosures about how Suno crawled and scraped the music using third parties in other countries. So I think that's very interesting, and one of the outcomes of that legal case is also the creation of other lawsuits, now including those third parties who are scraping music content. So that was very interesting. Yeah, I followed that with great interest. I think that's going to have very interesting implications on some of the legal issues in the U.S. To your earlier question, to what extent is human involvement even necessary? To what extent, to what level of involvement does it mean to be an AI musician or a human musician? I mean, I think there's not really a real strict definition of even what passes the bar for an AI musician. I mean, a piece of code that will automatically just go online and keep generating songs, repeatedly. There is ultimately a human behind it who's running that software. So, but yeah, increasingly so that involvement is decreasing and becoming more distant from the actual product. So yeah, it really is quite questionable. But to Elena's question, the term spray and pray is not from me, it's a great term, right? But it describes what happens in general with these kind of slop systems, which is that they had to sustain themselves somehow, right? This is the same thing with spam. So even with internet spam emails from the early 2000s, there's a great research study called Spamalytics from University of California, San Diego, from some really good friends of mine. And they did a fantastic study just analyzing how it is that this economy sustains itself. Somebody has to click on the spam, and then they had to go to a website, and then they had to buy and spend money to buy some of the fraudulent goods or fake pharmaceuticals or whatever to actually sort of funnel money back into that chain to keep it, viable. And that's what we're seeing here today as well, is that whether it's sort of AI generated slop in ebooks, or whether it's images being sold as sort of art, whether it's AI slop in music, all of them have the same model, which is that you're generating so much of it with minimal cost, minimal intention, minimal time, right? With the hopes that you are trying to create something, effectively a shotgun approach. If I just shoot a shotgun at everything, hopefully something will hit the target. And by hitting the target, the spammers or the bad actors are hoping that, some small portion of it will come back and produce some profit. And that profit will come back and fuel the entire chain over again to keep that whole machinery going over and over. So yeah, that's the spray and pray sort of methodology behind all this slop.
And in your paper, you actually are asking the question of whether it can be sustainable, right? It's similar to the spam
Yeah,
example. And your paper kind of answers this question. And the answer is yes, because why not?
right. Yeah. I mean, it's not definitive yet, right? Because a lot of this right now, I think, is fueled by hope and prayers. And some of these AI spammers who are doing this right now on the music platforms don't know what will hit. They're sort of still in a process of refining that methodology and perhaps trying to find better ways to deliver that slot music. Um, but it is the case that there are AI generated music on these platforms that are becoming profitable, that are generating hits. But it's also that there are more viable ways to make money off of that than just doing pure AI slop, right? So I'm sure many people have read about the fact that and understand the fact that Spotify pays royalties to anything that belongs to someone else, that's been written by someone else. So it's certainly in their own interest to basically produce their own AI music and to have people listen to that, because then all those listens, all that portion of the royalty pool is effectively goes right back to them. They don't have to actually pay out royalties for that. And so, for platforms like Spotify, there's certainly an incentive to create and sort of, advocate for the growth of AI music on their platforms. So yeah, so it's not just spammers; it's also platforms who can stand to profit if they don't have to pay human artists.
What I also liked is, um, again, coming back to your paper, uh, that the distributors they're essentially disagreeing on their own AI policies, and everybody is going their own way, sort of, with that thing. The only thing that they sort of converge on is they prohibit impersonating existing musicians, etc., etc. And the interesting thing was that you mentioned as well in the paper that the streaming services lack essentially stands on AI. And again, it's a mixed bag of different companies going different ways. And
Yeah.
That brings me to AI music slop detection methods as they are currently today. Are there any, and how effective are they?
Yeah, so you're right. So these are some of the bigger points that we covered and learned from the process of that study, right? A big part of this is that, when you look at the music distribution business and the ecosystem as it stands today, it is designed to deal with humans. So here, let me show a little diagram of sort of what this looks like. I think I can do that. Okay. Let me see. Share window. This one. Okay. So hopefully you can see this very simple diagram. This is just showing effectively what is the structure behind, what is the system, what is the flow of creating and distributing music, right? So very simply, if you're creating AI music, you just create something from Suno, Udio, any number of these other generators. You send it to a distributor, and distributors, have the job of potentially vetting some of this music, looking for duplicates, making sure that it doesn't violate copyright, etc. And then once it passes them, it goes to the streaming platforms. And it's interesting that, distributors, if you look at all the distributors out there today, they are all very sort of, all over the place with respect to what they allow in terms of AI music generation. Many of them do not allow AI generated music, or they say they will not distribute AI generated music. But there are others that will say that they allow it. But through our experiments, what we found is that it actually doesn't matter, because effectively speaking, none of the distributors have a really effective way of detecting what is AI generated music from what is human generated music. So even the ones who say, no, 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 we have a policy against distributing AI music, effectively distribute all the sort of AI generated samples that we've uploaded, simply because they can't tell the difference. They have no way of definitively telling what is AI, what is not. And coming back to your question of, how do we detect this stuff today? It is really difficult. It's the same question that we have when we want to detect AI generated art, quote unquote, or AI generated images. And, is this human art that's, digitized, or is this simply, something from Midjourney or one of these other models? And in every modality, it's a little bit different. There are ways to tell. Without getting into specifics about some other things, I'll just say that in the music side, um, it's, there's no effective detector, except on Deezer. So we tested a bunch. And the only thing that kind of did fairly accurate detection was this proprietary model that was built by and released by Deezer, the French streaming platform. But it was only available to people who subscribed to Deezer. And so we were a little frustrated with that. But thankfully, the Deezer folks, published their research, gave really, really cool details about how to do their model. And so we effectively just followed their instructions and built our own model for detecting AI generated music. And we released that. It's this little thing called Quicksilver. You can download it. It runs either in your browser or as a separate app if you're running Mac. But yeah, you can basically feed it 30 seconds of whatever you're listening to, and it'll, with very, very high accuracy and basically zero positives, false positives, it'll tell you whether the music you're listening to is AI generated or not. So that's been nice. At least now we have something to tell what is AI, what is human music.
How many
I feel
of
like it's
those
almost like, oh,
distributors?
sorry.
No, it's fine.
No, I was just thinking, I feel as a music consumer, and also kind of, performer sometimes, I just wonder whether how the industry will progress, if we will employ those tools and are kind of, scale them as well. So it's almost like, will your Spotify subscription come with like AI music detection feature? And then as a user, consumer, you will have a choice. Some people don't mind, say, oh, I don't mind. I mean, it's the AI generated. I will subscribe to that. And others would say, no, absolutely not. We're opting out, or at least we would like to have that feature in
Right.
my streaming service. I'm just thinking from like also business perspective how that could play out. So I don't know. There might be something there.
Yeah.
It's just
Um,
something I just came up with this. I haven't thought about it
yeah.
before. It's just kind of a
Well,
thinking out
it's
loud.
happening.
It's happening.
It is happening. Well, let me clarify. So, what is actually happening now is that the music industry, the labels are taking action. I've been talking to them, to some of them. I can't give away too many details because I'm not allowed to, but the industry itself is very aware and very concerned about this. And whether it's individual labels or groups of them, they're taking action to try to test and understand how different technical tools work. Spotify and Apple Music, I think, are also taking steps now, promising to give more transparency. I mean, that's effectively what we're asking for, right? Which is to say, different people can have different interests, and it's all fine, but what people need is they need information so that they can make their own personal decisions about, do they want AI music to be a part of their listening experience or not. So that level of transparency is sort of really critical. I think Spotify is making sort of steps towards that. I think Apple Music is also. And I know that the record labels and recording companies are also sort of pushing for more transparency and more explicitly clear, sort of very transparent labels on whether something's come from AI or not. It will get more complicated in the sense that Quicksilver, our tool for detection, only focuses on 100% purely generated AI output. But there's already increasing signs that real human musicians are sort of building hybrid songs where they're taking a stem that is AI generated, let's say vocals, and then combining it with instrumental and other stems that are actually human created. And so that becomes much more challenging, not only from detection, but also from a perspective of, what is human, what is AI? Are you okay with some partial AI? So yeah, so I think, constantly evolving, and everyone will have to sort of go along for the ride and figure out where it is that they live on that spectrum, and what they're comfortable
Yeah.
with.
Are we done with the music flop? Can we switch topics? Alisa, you need to keep tabs on
Yeah,
me,
I think
otherwise I'll
this is a really
diverge.
good segue. Yeah, I think this is a really good segue into watermarking, because what we're actually discussing, I think that is just with related to music, but this concept is applicable across the board in terms of how, provenance, watermark, like provenance is a lot larger issue, but how you actually implement the processes, what kind of tools like automation you have, to just mark this content as AI generated, notwithstanding whether it's music, code, literary works, paintings, images. It doesn't really matter, I think, conceptually. And I think this is something that you guys would want to delve in, because I will have to jump off in a few minutes, unfortunately. But yeah, I think that's a really good point, Elena. We can. Um,
Where do we start?
yeah. Oh boy.
So I segued the right way, right? That's very good. Like I said, I've been rusty. It's been quite a few months. So quickly, let's discuss the latest. Everybody has been losing their minds for some reason. The latest news that Anthropic started watermarking its outputs, Claude's outputs. Obviously, the EU AI Act is in force, and Article 50 is now in force as well as of August 2nd, and transparency obligations kicked in, et cetera, et cetera. Ben, for the people who are not really in the space, so to speak, and not really interested in watermarking, or have not been interested until Anthropic announced it and everybody lost their minds all of a sudden. How does it work? Or
Yeah.
better yet, is it even effective?
So, right, great questions. So I teach this in my AI class, for example, AI security class. You know, uh, Watermarks for generative text models, like large language models, have been around for a while. I think the first paper on this that is still largely the blueprint for most of these watermarks today was published in 2023, I think. So literally 3 years ago, more than 3 years ago. And it's fairly straightforward. It does work. The watermark is not like a obvious signal that can be easily broken. It's actually a little bit nuanced. Basically, what it does, it's a statistical sort of bias, if you will. If you look at if you take any model and you say, well, what is its normal likelihood for given question A, it'll say, give you answer B, and it'll use a certain random choices of combinations of words, right? So it'll try to say certain things, it'll try to give you certain things, but as it's generating the output, it always can choose from a bunch of different words that say very similar things. And every sort of iteration, every time you ask the same question, it'll run effectively a random number generator. It's kind of like rolling the dice and say, do I use this word or do I use this word? Do I formulate the sentence like this or that? And so these watermarks, what they do is they add a tiny little bias to certain words that make them certain words less frequently used and certain words more frequently used. And by doing that, what happens is that you can't just, identify a watermark by looking at a few words. What you actually have to do is you have to look at entire sentences, and then you have to combine multiple sentences together. And the more words that you see, the more obvious this sort of tweaking on the bias of which words are preferred and which words are slightly less preferred becomes more visible. Now, the tricky part with this is that even though it is a fairly reasonably reliable type of technique, there's a couple of things. One is that it's fairly straightforward to break it. What you have to do is, as you can imagine, it's all about word choice. So if I take a paragraph that, a particular model came out with, and then I basically send it to a different model and I say, randomly rephrase this particular paragraph. Give me the same meaning, but just use slightly different words, right? And that'll basically break the signal because it's all about word choices, right? And so rephrasing, that's what we call a rephrasing attack, will work fairly well on these watermarks. And even if, one round of rephrasing doesn't completely erase the watermark, if you just run it a few times, basically, it washes away that tiny little bias that in probability that you embedded in. That's one. Another more important thing is that the way that these models are all designed make them kind of useless in practice. And this is why I don't mean to, but I kind of chuckle a little bit when I see people losing their minds over this stuff, because people are freaking out. They're like, oh my God, if I, have Claude or something edit some of my text, I'm going to be outed as an AI user. What's going to happen to me? And well, first of all, I mean, if you just edit a few words, like I said, it will not, be a strong signal, right? Because this whole watermark idea relies on lots of words stringed together, and they all push a certain way. And then you get this tiny little weak signal repeated over and over and over and over, long enough for you to basically pick up on the real signal. But more importantly, people are missing sort of a key piece here, which is that the way that these watermarks work is they require a secret key that is absolutely necessary in order to read the watermark. But of course, as it turns out, this is the problem with these watermarks. If you have the key, which means you can read the watermark, you can also destroy it. You can also forge it. You can basically effectively make it completely useless. And so this is the problem with these watermarks. Effectively, it means that in order for them to be effective, the only people who can read them are the people who embedded the original watermark, right? So that means if, you got some text from Claude, only Anthropic can basically read whether there's a watermark from Claude in that piece of text, right? So imagine now, people thinking, hey, well, maybe this will be useful for like teachers to figure out which students, where this student got this text. Was it from model A or model B or model C? No, it's not really useful that way, because a faculty member or a teacher cannot walk around to every single AI model and say, did you write this? Did you write this? Did you write this? And have everyone check for their watermarks. And then, of course, ultimately, because only the creator can, read these watermarks, they have the absolute sort of leeway to say yes or no and to potentially deny watermarks even if they exist. So if if Anthropic, someone used Claude to write something really offensive or dangerous or whatever, and it comes back to them in court, and people are like, oh, did Claude write this? Anthropic can just look at it and be like, oh, this is really bad stuff. No, we didn't write it. And no one can prove that they're wrong, right? No one can say that they're lying because only Anthropic has the key that actually can tell, allows you to read whether a watermark actually exists or not. So all these things combined together, it just means that they're not nearly as effective or powerful as people think they are. But they're also not like the worst thing in the world. They just kind of are, and they don't really matter, to be honest. But yeah, I mean, Gemini implemented this 2 years ago, and I think OpenAI did the same maybe a year and a half ago. So Claude is a little bit late to the game, but I think given where they are now in terms of visibility and sort of the quote unquote leader in the AI space, people are paying more attention to it and getting a little bit more worried about it as a result.
That was that was something interesting that struck me as well, like the amount of all the outcry that happened. In the meantime, companies were watermarking their outputs, at least for a few years now, like you said, but for some reason it just struck a nerve
Yeah,
this time around.
yeah,
That brings me to the point of there are a lot of misconceptions, right? Because obviously it's we still, I hate this phrase early days, but it's early days, whatever is early. um and a lot of people don't really know when it comes to uh AI generated outputs watermarking, and that's what I kind of, one of the things that I keep talking to people about. There are a lot of misconceptions when it comes to, as you mentioned, only, for example, Anthropic implemented those watermarks. Only Anthropic essentially will be able to decipher them and tell the outputs apart, right? Which one was generated by Claude or not. And a lot of people really don't know this, and they don't know how it works. And I don't think Anthropic did a really good job at explaining this to people. Essentially. And yeah, there's always this communication problem
yeah,
for some
yeah.
reason.
Yeah, I
Is
mean, you could
there
really talk about them kind of screwing up the communication on this process. They could have definitely done a better job.
Yeah, I mean, it's kind of too late for that. This question for you, Ben: is it true that AI watermarking somehow makes the outputs worse, or changes the output, or makes model perform worse, or etc., etc.?
Not really. I mean, I think what's important to remember is that these are all random token generators, right? I mean, Um, if you look at these models, I mean, they're software programs. So, of course, at their bottom level, they are deterministic. In other words, if you run the same input on the same, data, it'll give you the same answer. But they're designed to capture a random process, which is to say, when people communicate, when people say things, there's a lot of random stuff in our brain, and we can say the same thing in any number of different ways that sound a little bit different. And so these models are designed intentionally to have randomness. They have a parameter, what they call temperature, which just means that by default, if you have temperature of 0, it just means you will say the same exact thing to the same question every single time. But because that doesn't seem human enough, that doesn't seem interesting enough, you want variety, et cetera, they additionally just intentionally add randomness so that you're not always picking the slightly most likely, the absolute most likely fitting word. You're going to sort of fall back on number 2, number 3, and so on. And so, yeah, so that adds variety, it adds randomness, it adds some unpredictability. It's quite likely it also plays a part in introducing a bit more hallucinations in the process. But yeah, I mean, that's part of the generator process. So when people look at generated text and these responses from these AI models, they think that, this is something deterministic. They think that this is like this optimal, this is the best answer it can give, when in fact, every single time that you ask it a particular question, it's rolling the dice underneath the covers, and basically based on that, it's giving you one version of any number of potential answers. So yeah, I mean, when you watermark things, you're going to play with the probabilities a little bit, but it's not really affecting the quality in any meaningful way, not in a way that we can really detect, because there's so many ways of saying the same thing. and there's already that randomness anyway. So we're taught to tolerate a wide range of errors and awkwardness and different types of behavior from these models as they output things. So what we see any potential changes from watermarks, that's just well within the noise of random things we're getting out of these models anyway. So yeah, it's very difficult to actually detect that in practice. Long-winded answer, sorry.
No, no, no. I mean, that was the best way, the best, shortest way to answer this, I would assume. And to the question of people being worried about, AI watermarking and being outed as, using generative AI to write stuff, et cetera, et cetera. There are already a few companies that are offering you platforms where you can humanize your AI writing and make it more human, and rounds and rounds of kind of this like washing cycle of your AI generated text. So on the other side, it's going to come out as supposedly human, and all this effort and time is spent on that. But maybe it's just easier and less time just to write your own text. I don't know. Maybe it's just me and I'm old
Yeah.
fashioned.
Yeah, I mean,
Yeah.
there's some irony in how much energy and time we're spending to make AI generated stuff look more human,
Yeah.
when in effect, AI is supposed to be, making things more efficient and faster. But yeah, I mean, there's this whole process. But as you well know, like a number of law firms now, have very strict policies on how people use AI models, and what's actually being used to write briefs, for example, stemming from all these embarrassing events where people use AI models to do whatever, and then the briefings have hallucinated case law and non-existent citations, all these things. Um, so I can understand some people, really being interested in sort of making sure that their AI text looks real. Um, but aside from watermarks, there's lots of other tools out there. We've done research with Pangram. It's probably the most popular AI text detector out there today. Very accurate. We've thrown everything we can at the system, and it's pretty darn accurate. Very, very accurate for text that comes straight out of the models. But even against things like, as you mentioned, these services called humanizers, right? Even against text that's gone through some of these humanizers, Pangram is pretty darn good at detecting when something's been produced by AI, right? So I think, yeah, for the people who are really concerned about that, I would say perhaps watermarking isn't really the biggest concern. You can certainly break watermarks fairly easily using humanizers and rephrasing attacks. But there are stronger tools like Pangram that may not tell you exactly which model produced the text, but it will tell you with high probability that it did come from AI. And so, you know,
Yeah.
again, that's muddy waters, and there's people talking about false positives and those kind of things. But in our tests, we've shown it to have fairly low, very low, I should say, false positive rates. And that's something that they can tune, right? And they do tune it so that even at the cost of
I think they're
potentially
like
missing some AI
on the
output.
fourth iteration of Pangram. They keep updating it, and it has to keep
Yeah,
up.
yeah, exactly. And they keep going back and forth with these humanizers. They need to perform well despite people using humanizers and so on. But they do pretty well. They do a pretty good job. So yeah, there's hope.
Why Substack just, they partnered with Pangram, and I'm sure you know this. And there was a bit of an outcry as well.
Yep, yep,
All the newsletter writers who were using
yep.
AI until then were
And
just a
I
little
think,
disappointed.
yeah, to your question earlier, I mean, I think people have to come to terms with, if you're using AI to as part of your workflow, and you're using it to sort of be faster or more efficient or save time or whatever, then you have to own it. I mean,
Yeah.
effectively, that's part of the process, right? I mean, if AI is supposed to be so great, then what's the problem with, owning the
Nothing
fact
to
that
be
you use
ashamed of.
AI?
Yeah.
Yeah, right. And perhaps if it is the fact that you're ashamed of it, then perhaps there's a reason, and maybe people should think harder about what that is, and whether that warrants actual human effort to produce something yourself, rather than to produce AI stuff and then try to work extra hard to hide the fact that you use AI tools to produce it. So you know, it's a convoluted, complex issue.
Very fascinating, and that's why we have
Mm.
it today to break things down. And we
We'll
have
see
only 20
how it
minutes
goes,
left.
right?
You
Yeah.
have 20 minutes to talk about AI model provenance and distillation. And I want to talk about another paper of yours. One of your students actually gave a short presentation on that topic, and you were kind enough to share the link for that as well. And yeah, let's talk about model provenance and how can third-party auditors or researchers or regulators, you name it, how can they find out whether that model came from model A or model B, for example? How did it come to be, or whether the company that claims they trained that model on a certain data, et cetera, whether if it's true, given that obviously lack of transparency from all the companies and they're mostly closed models.
Yeah.
But nevertheless, you guys worked out and developed a system that could look into this black box and, kind of tell where the model came from and where was it distilled from if that method was used. Obviously, not the only one. So if you can please speak on that a little bit as well.
Sure. Yeah. I mean, it's like the Wild Wild West out there, right? So everyone can produce their own model. You have little startups and companies or groups that you've never heard of popping up one day and saying, hey, we've got our own model. It does better. It does this. It does that. It's all ethical. It's been trained from scratch on licensed data, et cetera, et cetera. And one of the challenges is that you can't tell. You have no idea because everyone protects their model like it's magic behind a black box. So you can ask it questions and prompts, but you can never actually get the model weights yourself. So how do you know if a model is actually trained from scratch, or maybe someone just took an open source, open weight, whatever you want to call it, model, tweaked a few things, all of a sudden all the numbers look different, so you can't immediately recognize it, and then they say, well, look, this is our own, proprietary model. It's magic. Don't ask questions. Just use it, etc. And the answer is it's actually not that difficult. And the simple idea is this, that when you train a model from scratch, you spend a ton of compute hours and computing resources, and you use a ton of training data. And what that does is when those things combine together, you train this sort of very complex. Think of it like you know the internals of the model itself, right? And mathematically speaking, it's a very high dimensional space, so it's not 3D. It's more like, I don't know, somewhere around 900 to 1,000 dimensions. But really, what it means is that that process that you took with that training data and all the compute defines what that inside of the model looks like. But it turns out that is also why it is so difficult to make it different. Right. So when you take someone else's model and you just, tweak it a little bit, reshape it, add a little bit of data, a little bit of compute, you're just not able to change much of the model internals. So most of this, 99.99% of the space, it's basically largely unchanged. And so what our tool does is it sort of exploits this fact, right? The fact that the more the model internals you want to change, the more money it'll cost, the more data it'll take. And so what we do is we just generate these very specific, detailed prompts to, let's say your mystery model that you're trying to figure out. And in this case, we're targeting mostly image generator models, but you can do very similar things with LLMs. And you ask it very specific things. Give me an output for this particular long-winded prompt about, let's say, birthday cake. Okay, it'll give you a specific image, and if you just repeat this, let's say 100 times, it'll get the randomness out of the system, and you'll get a collection of images that are all around that image prompt. And then you can do this with lots of other different models, right? So models that already exist out in the public, commercial models, open source models. And then you can look at the statistical properties of these images, not any single image, but these groups, and then you can mathematically determine their similarity as a set. And it turns out that, even though when you look at some of these images, they might look same, they might look different, whatever, it doesn't really matter. But mathematically speaking, you can characterize them in the embedding space, and then you get, mathematical distances that sort of come out. You can say, well, this mystery model is very, very similar in mathematical space to a particular other model that we know of. And it turns out that if you just tweak a certain model, and whether you call it distillation or distilling it or fine tuning it, whatever, or even just renaming it, you're basically going to have output that very, very closely matches the output from the original parent model. And in contrast, if you have two different groups that train a similar kind of model, even sometimes when they use very similar training data, the internals of the models that they produce will actually be quite different. So intuitively, I sometimes use this analogy of thinking about, like, you walk into a dark cave and you can't see the very large cave and the surface and all the spice coming down and so on and so forth, but you can pick up your flashlight and point at a few particular locations and see where the light goes and what you find. And effectively, that's kind of what we're doing with the internals of these models. We have a certain set of randomized flashlight positions that you point at, and then you compare and contrast the things that you see in those particular locations across different models. It's kind of like your fingerprint, and key features in your fingerprint, really. So it's, effectively speaking, kind of like a model fingerprint technology, and it works really well. It is very difficult to break or bypass, because really bypassing it means that you have to change the model internals, which actually means that you have to spend a lot of time and money and potentially get a lot of data, which comes back to the whole point of this is what you're trying to avoid in the first place, right? By trying to distill or fine tune a model. So, yeah, that's tools out there. We've already actually used it in a legal context with a group that was doing a legal investigation, and it actually worked out really well. So, yeah, we're pretty happy, and hopefully this tool will be able to help regulators and legislators and other parties in this space.
Like I said, it's fascinating stuff. And you covered fingerprinting, model fingerprinting as well. I wanted to kind of touch upon that as well. You got my question before I could ask it. So sort of, like users who are using ChatGPT a lot, Claude a lot, at some point, kind of you already can tell when you're just talking to a model, you already know kind of the way they talk. So just on some level, you're like, okay, Claude is like using certain verbs, and some things you on
Yeah.
some internal level, like if you're using those models a lot. So essentially, is that kind of what you guys were doing, but with computation and numbers, et cetera, et cetera? It's just like humans on this kind of intuitive level. If I don't see the output of that model, whether it be in ChatGPT or Claude, I will be able to understand just from that text which model I'm talking to. Kind of. Is that?
Yeah, it's similar. I would say that in the context of chatbots and LLMs, it's a little bit different in the sense that, with image models, it's easy to get at the cores, the core sort of pieces of the internals of the model. With text, it's harder because you can take the same core model and you can do very little bit of training, superficial training on top of it, and make it sound sufficiently different. So, for example, if you do some, sort of external alignment training with some of these models, you can take GPT, you can take one of these other models and basically say, be extra critical, all right, or by default, use more sort of down to earth verbiage or language, right? And what will happen is that even though the model internals are the same, because you've given it these basic general instructions, it'll dramatically change the words that it uses to communicate with you. And so in LLMs, it's actually quite easy to make it sound different. So you have to work a little bit extra hard to get at the core internals of the model. So you effectively have to use simple jailbreaking techniques to get past sort of the outer superficial instruction chatbot version to get at the core of the model so that it's going to reveal more of the fingerprint to you rather than, someone giving instructions, oh, be extra nice to Elena whenever she talks to you. And then all of a sudden it sounds different. Yeah.
Oh, I can do that 100%. You don't even have to prompt me. Alice is not here, so yeah.
Right.
I'll keep it short. A few words on the flip side of model provenance and be able to glimpse on where that model came from. Your paper mentions adversarial attacks and other ways, like what other ways it could be used against the model, against the developer, et cetera, et cetera. Knowing where the model came from, that is, right?
Right. I mean, generally speaking, transparency is a good thing, right? But I suppose, there are times if you are licensing from a particular company or, you have some sort of agreement with a different model creator on using their model, but doing so in a more anonymous way. I can see a potential legal circumstance where you license a company's model with the explicit agreement that part of the deal involves anonymity, that no one discloses that you're using their model or a variant of their model, right? And so, so in circumstances like that, this will sort of break that. And this will sort of paint a clear link between your license model and the original parent model. But in general, I would say, transparency tends to be a good thing. Especially right now where you have marketplaces where, random third-party models are coming out of nowhere. You don't know where they're coming from. Are these being trained from scratch? Are they, just copying and misrepresenting someone else's model as their own? Because without tools like this, it's really impossible to tell, right? And so I would say, there are potentially some corner cases where I can think of where this might be misused, but generally speaking, transparency is mostly a good thing under almost most normal operating conditions, and it helps everybody to understand where things come from, particularly right now where you have regulators looking a lot at this very chaotic marketplace, lots of models arriving and no one knows where they came from or who trained it and how.
Yeah. I think we lost track of how many models currently we have. You just go to GitHub and you will be amazed at the number, I would say. I mean, I'm talking about the open source models in that instance, but yeah, there are tons of others as well. So we have a few more minutes. Let's talk about distillation real quick, because a lot of people are throwing this word around. In my experience, a lot of those people are not really familiar with the term, unfortunately. So quickly, as a background, in February of this year, Anthropic came out with this report and they accused a number of Chinese companies of distillation. I believe it was Moonshot, and Minimax, and DeepSeek, obviously. DeepSeek is always there. Can you please talk about model distillation? And obviously, it's not something illegal models. Everybody's doing it when they're training their own models. Obviously, big AI companies are doing that as well when you want to train smaller models. But in that particular instance, what is your opinion on that? Was Anthropic, kind of right to, throw that news out there and just accuse those companies of distillation, et cetera, et cetera? How do you think that played out?
Yeah. I mean, it's a very interesting topic. So let me a little bit of background first. So distillation is a thing that's been around for many years, but it's not how people think of it as now. So distillation is this process of taking an existing model that you have and effectively transplanting it onto a slightly different architecture with the same properties. So it's like I have a big model that I train, and maybe I want to make it much smaller. So I try to distill it onto a smaller architecture. I can do that because both models are fully within my control. So I can effectively take a model that's big and I can just sort of squish it and fit it into a smaller model size. And that's oftentimes done in the process of training, right? So that's distillation. It's like, boiling water, letting it condense, and then becoming liquid again somewhere else. So that's where the name comes from. Um, but in this context of, I don't know whether you can call it sort of international espionage or sort of corporate, competition or whatever, it's a little bit far-fetched. I think now the term is now being used in this context, as someone basically going to a model that exists, Claude, GPT, whatever, and then trying to produce a smaller version of that model, by taking shortcuts, by taking results from an existing model, right? Maybe you're, benefiting from an existing model like GPT or something else. And that actually, there's a name for that too. It's called an extraction attack. And that's what we actually call it in AI and security research. It's called an extraction attack, to take an existing model, ask a ton of questions, and then use the output to train your model. That's called an extraction attack, not distillation. But somewhere in the translation process, people who talk about these kind of things in business and other contexts, who are less familiar with the literature, sort of started using distillation as that term, which is fine, whatever. But to be honest, it's difficult to sort of imagine that it's actually happening that way, right? So let me give you some reasons. One, these models are so massive. These models are trained on trillions of tokens, billions, many, many billions of documents, terabytes and hundreds and thousands of terabytes of data. And so you have to think about like the complexity of these models. If they're trained on terabytes, many, many, and again, thousands, hundreds and minimums, but quite likely thousands of terabytes of data, how many times do you have to ask Claude different questions in order to get every possible Claude behavior from its training data into your own model? That's insane.
I'll tell you how many times. Anthropic uses the number 16 million exchanges.
Right. So one would argue that that's impossible, that 60 million exchanges is nowhere near, not even the order of magnitude that you would need to produce the perfect training data, right? So really, like, thinking about like the number of documents that goes into training data, right? And again, even if you were magic and you could create these perfectly structured prompts, because the other problem with these questions is, what if they're redundant? What if they learn things that you already learned in the last 2,000 questions, right? So all the questions have to be different. They also have to contribute and add some other piece of information that was not there before in order for it to be useful. So you're talking about 60 some million independent questions that are well structured to produce valuable data that the other questions have not. So that is already a massively daunting, difficult problem. But even then, it would not be enough. It would not even come close to 1% or perhaps less of the training data that these things are trained on. So, and then you have to look at the scale of these numbers, and you have to say, well, I mean, gosh, if someone is, again, I don't train models, and I'm not in the industry. I don't run these things. So all those caveats out, first and foremost. But I can imagine that if I'm hosting a service like Claude or GPT or whatever, any of these commercial models, and if I see 65 million questions coming from the same company or location or user account or any combination
there were different
thereabove,
accounts.
I would say,
Ben.
okay, that's a little bit unusual. And, having worked in security and done research in security for, a few decades, there are tons and tons. There's decades of research on how to detect anomalous behavior, when there's outliers, when there's spikes and peaks in traffic and user accounts. All these things that you can use to basically identify when someone's going after you and basically shut them down. So the question is, why was that not done, right? If I'm running a model service, I can make it arbitrarily difficult for someone to come after me to extract that kind of information.
Let's not forget, I don't think Anthropic even allows their model to be used in China, right? It's Chinese citizens are not, like, they can't get access to the model itself. But nevertheless, 2,400 accounts were created according to Anthropic in order to, create the outputs, etc., etc. So again, communications problem. Are we coming back to the same communications problem?
I think from a security standpoint, something's a little bit off, right? Maybe an attack happened. Maybe there was negligence in letting some of this stuff happen. I don't know. Nobody knows, right? Nobody knows except Anthropic what all the details are. But I just think that from an outsider standpoint, it seems kind of far-fetched and really, really challenging. It may be doable, but it almost seems like you would have to have a lot of things happen in a particular way. You have to miss the signals, you have to ignore the signals, you have to have very high speed networks, you have to have poor account management, poor traffic checking, tracking, all these things have to happen for this and to happen for a very sustained long amount of time before this can happen, before this can actually succeed, right? So yeah, I mean, maybe there's a little bit of that, right? But it is about the volume. And I would imagine that it's possible for someone to what do they call it? I mean, you can do some sort of fine tuning with feedback from a particular model, so that you sound a little bit more like a particular model. I think that's doable, but I think there's a big difference between that, tuning a model to interact with you a little bit more like Claude, a little bit more like GPT, than to say, oh yeah, you really took their model's inner core knowledge and sort of extracted it somewhere else, right? So I think the truth is probably somewhere in between there, but at least from face value, from outsider standpoint, it seems very, very challenging to do, for whatever that's worth.
Listen, I will defer to you on this matter. And it's fascinating stuff, and it's great to talk to you about it. Just, it's always great to talk to a person who knows quite a bit when it comes to those things. And I'm sure it's not our last interaction. I hope we will have you on again at some point. That would be the part when you say yes. Yeah.
Sure.
100%. And now I have you on camera as well. Thank you so much, Ben. Thank you so much. Lisa, unfortunately, had to go.
Yeah.
Left us in the middle of such a fascinating conversation.
Well, work calls, but yeah, thank you guys for having me. It's been so much fun.
Thank you so much. Thank you so much, Ben. And I'll see you sometime on and offline, maybe.
We'll see you soon.
Thank you so much.
Thanks.
Bye, everyone.
Bye-bye.